Hello, everyone, and thank you for joining us for today's Fiber Broadband Association webinar. My name is David. I am the webinar producer here with Fiber Broadband Association. We appreciate you taking time out of your busy schedules to join us today. Today's webinar is the benefits of network automation in global networks. And this is webinar number 3 of a series that's presented by NTT DATA. So we're pleased to have them joining us again here today. Before we get started, I do want to go over just a few brief housekeeping items. First of all, as attendees, you are in listen-only mode. However, we do want to keep this interactive. If you could, if you have any questions, please type those questions into the Ask a Question tool, which is located in the lower left-hand side of your screen. And we will incorporate those in the conversation throughout and also have some dedicated time for Q&A at the end. So please do share any questions or comments or feedback that you might have that way. We also have several resources, including links to the previous 2 webinars in this series. They are located in a tool which is in the upper right-hand side of your screen. I highly encourage you to check those out, again, as part of this, this series. And I'll also include all of these links to all the resources. This will also be in the follow-up email that you will receive as an attendee. This will be available on demand as well. We will be sharing that through our website on fiberbroadband.org, usually within 24 to 48 hours after the live broadcast. So look for that if you wish to share this with your colleagues. And finally, we do have a brief feedback survey at the end of today's webinar. It's a pretty quick survey. One of the questions in there is whether or not you'd like to have a continuous conversation about today's topic. If you want to have a follow-up conversation, you can use the survey to let us know. And the survey also helps us to ensure that these webinars are valuable for you. So we value your feedback. If you could take a moment to respond, that would be great. And with that, let's jump right in here. So today, as I mentioned, once again, we're welcoming NTT DATA, and today's presenter is Joseph Nicholson. He is the Network Operations Engineer of Global IP Network Division at NTT DATA. And with that, I'm going to go ahead and hand things over to Joseph to get us started. So Joseph, take it away.
Thanks very much, David. I appreciate it. My name is Joseph Nicholson. I am a Network Operations Engineer at NTT DATA. For the past 5 years, I've been doing a little bit less operating and more automation. So today I'm here to talk about the benefits of network automation in global networks. We're going to start with a brief introduction here in a minute. I'm going to talk a little bit about myself. I'm going to talk a little bit about NTT DATA, and then we're going to talk about the benefits of network automation in general. And after that, we're going to talk about a couple of ways that NTT DATA and the global IP network is automated, starting with our network configuration management system. And then we'll talk about our telemetry, and then we'll talk about a lot of the work I've been doing over the last 5 years with operational automation on the network. And then at the end, we will go over a few of the benefits of network automation that we see within our own network. And after that, we'll have time for some questions. So let's get started with the introduction. So I've been a network engineer for the past 25 years. I've been with NTT DATA and the Global IP Network Division specifically for 18 years. And I spent 12 years in the NOC. And then for the last 6 years, I've been on the network operations team. And about 6 months ago, we had a bit of a shakeup and redistributed the teams a little bit. And I've been on the network scaling team for the past 6 months, focusing purely on network automation of operational tasks and procedures and day-to-day sort of things. Who is NTT DATA? NTT DATA is a part of NTT Group. We're one of the world's largest telecommunication companies. We are a Fortune 500 list for 2025. NTT DATA as a global organization has about 30 billion in annual revenue. We are the 6th most valuable IT brand. We are a top 5 ranked IP network in the world. We're in over 50 countries. In 33 of those countries, we're a top employer, and we are the 3rd largest DC provider. Basically, we are technically and financially a safe pair of hands. Now, this slide shows the, while NTT DATA is a worldwide company, this slide shows the global IP network itself that we're responsible for. Our network spans 5 continents, throughout 40 countries, over 90 POPs, and it's 100% available backbone. So I'm going to give you an extremely very brief and nowhere near complete history of network automation. We don't unfortunately have enough time in this webinar to cover the actual history of network automation, but traditionally network management has been done via the CLI. I think a lot of people who have been doing networking for a very long time can, agree that that's their first entry, and usually today that's most people's entry into their day-to-day on managing networks. I want to say in somewhere between 2009 2013, hyperscalers started to kind of come into the market, and they started to realize that they have so many devices sprawling throughout their networks and their data centers that there's no way they can't not automate. There's no way that they can afford to pay, the number of people needed to automate that or to engineer that much networking equipment. So they came in and started automating all their data centers and their networks across the world. And then now here we are today in 2025, and for like the past 10 years or so, traditional network engineers are slowly starting to adopt network automation. For the global IP network as a whole, we've been automating for the past 25 years. We're network automation pioneers in the sense that we helped drive golden configurations from databases. That's something we've been doing for the past 25 years. That's something that's pretty new in the past 10 years across the industry itself. And we've also worked with our vendors to make sure we can have idempotent deployment of configurations into the devices. All right, so we're going to do a quick poll here. If everybody could take a couple of seconds to answer this. Poll question is, how would you self-classify the job position you hold, job or position you hold? Are you A, a tech, an engineer, or an architect? B, an executive, manager, or director? C, are you a NOC engineer or technician? And if you are, welcome. I have a soft spot for you guys especially. B, are you part of marketing? C, pre-sale sales? Oh, sorry, E, pre-sale sales. F, project management, or G, are you an analyst, subject matter expert? Give you guys a couple of seconds there. All right, we got some results in here. It looks like today we got a lot of marketing, we got a lot of pre-sales and sales, and then some executives, managers, directors. Don't worry, I like you guys too. Looks like the NOC guys are busy this morning. And then techs, engineers, and architects. So thank you very much, guys, for filling that out. Now we'll get on with the rest of the show here. All right, so some benefits of network automation. I just want to go ahead and say that this is general. This is not specific to the NTT network at this point, but these are just kind of benefits of network automation in general. Network automation can bring you improved efficiency. It can help reduce human errors, give you faster deployment, give you some scalability, increased reliability, network security. It can bring in cost savings. It can centralize the control of the network. It can help your engineers and your technicians with quick problem resolution. Provide analytics and insights, especially not only from the operational and the technical side of things, but from the business side of things. It can help make those decisions and stuff and back up all the cost and the money you want to spend with actual hard data. And adaptability with your network. All right. So I'm going to talk about our network configuration management system as the first system, first section here. So our network configuration management system is called the GEN Unified Management System, or GUMS for short. GEN standing for Global IP Network. The system was developed in-house starting in the late 1990s. We've got about 25 years worth of progress. This was a project started by the IP engineering staff in the 90s. There wasn't very many of them, and they wanted to be able to do things at scale very quickly and very easily. And now over time, and even up to today, the development is done by a dedicated team. So once they kind of proved that the benefit of the system itself, they, the company put some money into it and then hired up a dedicated team for that. The system itself currently manages 800 or more network elements, driving fully automated network configuration. This is not an autonomous system. It doesn't go off and do things on its own. It is just straight automation that requires a human to kind of press a button and make something happen. So the architecture of this particular system is at a high level, basically what we have here on the slide. The user on the left will use either the UI or the API to input data into that database. And from there, Python configuration scripts will go pull the information out of the database and use Jinja 2 templates to generate the full configuration. And once the full configuration is generated, it can be pushed and committed to the routers. And due to the idempotent nature of the configuration, the routers will parse that config and only commit or change anything that is actually changing. If we push a config that doesn't have any changes, nothing happens. The router just accepts it, commits it, and doesn't make change. So with this particular system, we're going to go back over that original list of 11 benefits for network automation, and we're going to see how that benefits NTT data specifically. So with this system, we can improve our efficiency pretty greatly. We are easily able to and quickly able to deploy new services, new features, make small minor changes to customer configs based on the requests, or even add in new circuits and remove anything that's going away very fast. It allows us to reduce human errors by using preset templates and having those tested in our development before they even hit production. We don't have to worry about anybody on the CLI trying to remember to type a command and accidentally putting in the wrong thing and causing an outage that way. So every operator, every engineer, every person who is working with this particular system is going to make the exact same change the exact same way every single time. This allows us to do faster deployment along with the improved efficiency like I was talking about earlier. Our customer engineers, if you get a new service from us or you want to change the service, they can very quickly and very easily set that up within our own system. And a lot of times we're more than likely just waiting for, either the telcos to bring a cross connect in, or, those things that are off of our network, we're waiting on those to take place before the service starts to work. Scalability, this allows us to have the network that we have with as few as people as we have, and we're able to expand that network at any moment and bring in new devices, new services, new POPs, new MSAs, so on and so forth. Increased reliability. With that configuration, not only are we, or with the templates, not only are we reducing human errors, but we are making it more reliable. Going back to that, not making mistakes on the CLI. That network is going to stay. It's going to stay up longer, and it's going to come back up faster when we do operations that require the network to come down for one reason or another, or parts of the network to come down. Network security. With the templating system and with the configuration management system, we are able to make sure that the network is secure, and every single router has the exact same features and ACLs and security involved. And we can, again, at scale, push out those changes that we need to make to increase that security much easier this way. We're also get some cost savings out of this. This allows us to kind of cut down the overhead a little bit, and allows us to work with fewer people. But also allows us to, do things, again, with faster deployment. Cost savings comes into play here. We're able to get you services much faster than other telcos. This also gives us centralized control over the network. We do this from one location, one UI, one server. We don't have to log into routers. If I want to make a change across every single particular platform across the network, I don't have to log into 80 routers one at a time making changes. I make the change in one place and I start pushing it out. This also brings quick problem resolution for the NOC. We've had many instances where something's maybe not working correctly, and it's really easy just to push a config again and reset it to see if that helps. Also, having the services and all the protocols set up using templates and with a common configuration The NOC knows and the engineers know exactly how everything's supposed to be configured every single time across the network. And there's no accidentally forgetting a particular knob that on a device because we're not putting it in via, entering via manually via the CLI. This particular system doesn't give us analytics and insights. We'll talk about telemetry in a second that does, but this system does enable that ability to get analytics and insights by having the configurations available and for the telemetry system to be able to pull information it needs to enhance the analytics and insights. And this brings us adaptability as well. You know, we're able to qualify and push out new platforms across known vendors very easily. We're also able to qualify and push out new optics very easily and new services like 100 gig, 400 gig, so on and so forth as they become available. Well, without having to do a lot of extra work. As long as it's a vendor that we already support, then we will pretty much be able to push it out really easily with this system. All right, now, let's see, a telemetry system. Again, this is an older system. It's been around since the early 2000s. The back end of the device pullers, some of them are the same as they were back then. Over time, we've had to make a few adjustments as the OSs have changed or evolved. The system is a little bit older, but it is very stable. It is very reliable. Over the years, as we've added new vendor platforms, operating systems, hardware technologies, protocols, we have been able to add new pollers and improve the technology behind that. So it's not the exact same pollers, you know, in some cases, especially with the Nokia being our newest platform over the last 3 or 4 years. You know, those pollers are pretty new and they're running on a little bit newer code, but they're still just as reliable as the older ones are. And this particular system does have multiple user interfaces. One of them is an older one. It's the original one that's been internally developed. The newer one is externally developed. You know, we maintain both systems because, you know, people can be used to the specific presentation styles. And those newer systems, especially when they're externally procured, does not always win out against the older internally built systems. You know, our internally developed tools are designed for the developers and the users using them, you know, to adhere to their particular workflow and about how the people think about our network. So it can make sense to kind of keep those things around so that everybody is comfortable with, you know, using them. The NOC also has a log and trap-based alerting system that they use in conjunction with the telemetry and the stats. The NOC techs and engineers have the same access to the same systems that those of us in operations and the IP development team has. We're not hiding any sort of data from them or anything. They're able to very easily see the exact same thing we are. And using these automation systems, the NOC is able to investigate and resolve 90% or 95% of all their issues that they see at the front line. There's no gatekeeping. There's no level 2 or level 3 escalations. The NOC does everything right there from the get-go. They have access to the same things I have access to. I am part of the on-call system, so if there is an issue and I happen to be on shift, they can easily page and ask for help, or even ask a question. I can't tell you how many times a day I get simple questions from those guys, just, you know, looking for a little bit of help. So it's very easily for them to reach out and ask for a little bit more if they need it. But for the most part, most of the time they are able to handle everything on their own straight up, and anything they have access to or I have access to, they have access to as well. So it's not like they have to go to escalation every single time, but sometimes it helps to get a little bit of extra confirmation or a second pair of eyes. All right, going back to our list of benefits. So with telemetry, we see faster deployment. We're able to look very quickly once we deploy something. Stats will start kicking in within a minute or two in most cases, and we're able to very quickly look at it and see if we start to see traffic or if we're starting to see errors or whatnot. We also have the CLI for that as well, but it's sometimes good to watch the graphs and start watching it build up and verify that it is passing traffic as we expect it to. This also provides us scalability, so we can look at a lot of things across the network all at once. We don't have to just focus on one interface or one router. We can look at multiple routers, multiple interfaces all at the same time. If I want to pull up every interface for a single customer, I can do that. So we can look at things at scale as opposed to just one at a time. This also gives us increased reliability. We can look at the history and the of the services and the stats that are being collected, and we can verify if we see any kind of long-term issues happening or if there's any way we can increase and improve the network as well. And then network security. This brings in stats that our security team does use to monitor the network and verify that everything is looking the way they expect it to. This also brings in cost savings again. We can look and see if do we need to increase bandwidth on one path and remove some bandwidth from another path to kind of reduce the little cost there. Also, being able to look at what customers are passing and everything else can help us reduce those costs too, and determine if we need to kind of shift where we're spending money across the network. And then quick problem resolution. We can very easily see if there's an issue. We're filling in all the errors and all the drops and everything else as well. Even not only at the interface level, but the queuing level and the QoS level, and as part of the protocols with like MPLS and BGP, so we can start to see if there are issues there. And in some cases, if there's an issue in one place of the network, and we can also kind of go ask the question, like, is this happening in other places on the network? And we can use this system to help us determine that. And this provides analytics and insights for sure. And then adaptability. All right. So the third section here I'm going to get to is operational automation and the global IP network. This is essentially how I spend my day. So we use a mix of Python and Ansible with a bunch of elbow grease. We like to use Python when we need to do a task at scale programmatically. And we'll use Ansible when we need to replicate an existing process done by humans, things like router upgrades, those things that are documented usually with a MOP that need to happen exactly the same way every single time. Ansible's pretty good with that. So operational telemetry, going in with the telemetry system I talked about in the last section, there are times where, from an operational perspective, we need to see certain things that the telemetry system may not yet give us that particular data, or we're just kind of curious about how things are going. And some of these have come because of issues we've seen in the past. Our telemetry team is a small set of a couple of people. We like to run lean and mean in that regard. And it's not always easy for them to assist every single team across the business unit and to meet everyone's needs all at the same time. But from the operational perspective, we have the ability to spin up a script really quickly and start sending data over there, collecting data and sending it over to that system to monitor things. There's been instances where configuration sizes have gotten out of hand, and we've had to ask the question to ourselves, okay, if it's happening, this problem's happening, or there's a problem happening on one particular router, where is it close to happening anywhere else? And to answer those questions, we were able to very quickly spin up a script to go pull that information off the routers that it applied to, and put that into the database and start monitoring it and seeing that, oh, yes, it is kind of sort of getting close to happening over here, or no, this whole section of the network is perfectly fine. We don't have this problem. So we've had many instances where we've done this. A lot of these operational telemetry scripts started out with me learning how to pull this data in the first place, but then it was also based on those issues. So we are pulling prefix data collected per ASN. We're looking at every BGP session across the network. We're trying to determine, how many prefixes are coming in, how many are accepted, how many we're sending out. This is all based on peer groups and prefix lists from the BGP sessions. But it's kind of good to watch this, and we can see over time and trends and watch who's sending us what and what's being withdrawn, and watch those numbers kind of fluctuate or watch them creep up, and kind of get a good idea of how BGPs how many prefixes are coming into the network over time. We also watch the router rib counts and across the different rib tables. This is something that's traditionally some networks have had issues with, operators have had to deal with in the past when the rib sizes, the memory sizes were really small. People would hit those without knowing that it was going to happen. So we can start watching these counts and watching these tables, and we can set up some monitoring and alerting on it. These days, routers pretty much have more memory than they need, so that issues doesn't really come up very often. But it gets good. It's a good stat to keep an eye on just in case, and you can kind of watch how your network progresses. And this is another indicator of network growth as well. As more routes kind of come into that rib table, you can kind of see how the network's growing that way from a different perspective, other than footprint and customer stats. Also watching again configuration sizes and flash disk sizes. We can watch disk space, configuration spaces. We can get detailed LSP output for MPLS protocol. We get detailed RSVP output for RSVP protocol. We've recently enabled out of bandwidth across the network. We can watch stats for that. So we can watch how LSPs are automatically growing and shrinking in size and how they're changing paths. And then watching, some of the newer technologies we're bringing in with DCO and 400 gig interfaces. We can watch those specific stats, which are not, while those come up on the interface like anything else, like bandwidth or drops and errors, those are not traditional stats that were put into the original stats system. So we've had to, as we put those technologies in, and they have brought in those kind of changes, then we've had to kind of come in and write some bespoke scripts to handle the collection of that data. And for those two specifically, we did write those scripts, and then the telemetry team did integrate that into their system as well. So we're able to help them kind of integrate things in and move it along. So these particular pollers are ones that I've worked on. They're about 5 years old. As I've learned and as I've worked on them, they've become a lot more reliable over time. So it's been a good learning experience even for myself to, figure out how to pull and use telemetry across the network. All right, so for our operational processes, when we use Ansible playbooks, right now we have a small set of playbooks, but they're all very interconnected and integrated extremely well. We use Ansible to upgrade our software across all of our routers. We've been doing this for about 3 years. This can bring some reliability and consistency to the actual upgrade process. So when we send you an email saying we're going to do a router upgrade, yes, the maintenance window is 3 hours, happening at 2 a.m. to 5 a.m. local time, but we at this point know that it takes roughly on average an hour to an hour and a half, depending on the platform. And you can rely on that consistency that it's going to be that way every single time. So we don't have to worry about different people doing it and doing it differently or taking longer than, another person might do it and stretching that time out. So Ansible's helped us a lot to make that a lot more consistent process. Okay, we also have a software package management, which allows us to, get prepared for upgrades. Anytime we have a new image or a new version, we'll put that into the system and it will get distributed out to all the routers by the next week and in time for the NOC to go upgrade. So again, that saves time with the upgrade process. The image is already on the device and all we have to do is apply it. And then we were able to take pre and post snapshots and then get some checks and verifications after those upgrades are done. The NOC will also use those in other situations like migrations from one router to another, from an old router to a new router, or any other process where they need to take the router down, whether they're replacing a failed part or upgrading parts to newer ones. They'll be able to run those snapshots, and they're running the exact same snapshots that the other automated processes are running. So it's the same output, the same checks, the same peace of mind every single time. We also have scripting to remove traffic or add it back once we're done. Sometimes we have to take traffic off to do a particular maintenance action. And again, this is the same set of tasks and scripts or playbooks that run whenever we do router upgrades and other actions. And then occasionally the things do go wrong and we need to contact our vendor and get a case opened. And when we do that, we have scripting to collect all that data. The vendors over time have asked us for large and large amounts of data, and it seems like the list is always growing. So we've been able to automate that. We'll collect the same thing every single time, and it's much, much quicker. And the technician can kick it off and go do their thing and then come back and they're ready to start attaching it to the case. And then our customer engineers also use Ansible right now to do circuit testing. So when they turn up a new circuit, they're able to do really quick hour-long tests in each direction. And then the automation can very quickly check all the stats that it needs to check and verify that everything looks good and that the circuit is ready for use. And then for Python scripting for our operational processes, this year, we've been going very heavily and trying to spin up new scripting to do things like, circuit turnups for our backbone circuits. So once the circuit testing is done, a ticket gets opened with my group, and then we're able to run another script that will allow us to go turn that circuit up, verify that it's good to go, and then normalize it and put it into production. Or if it doesn't look good after we put traffic on it, to remove that traffic and let us know, hey, we need to look at this further and do something with it. Later on this year, hopefully about Christmas time, it'll slow down enough. I'm going to go ahead and rewrite the circuit testing into a Python script, and then I'm going to marry those two processes together. So that'll allow us to do is customer engineer will be able to go ahead and test that circuit like they have been. And once that circuit comes, is good to go and ready for turn up, it'll go and start getting turned up immediately, as opposed to waiting for somebody in my group to get around to picking that ticket up and getting that done. So we'll be able to push out new bandwidth and new circuits across the backbone itself much faster that way. We also are I'm finalizing the DWDM shelf turnups and removals right now. We do have a little bit optical system for internal use across some of our MSAs, and being able to turn up those shelves and those systems can be quite complex, especially for traditional network engineers who are not used to dealing with optical. And so we've automated that process, and we're able to kind of turn those up much quicker and with less of a headache and more reliably. Over time, coming up in the future, our list is we're going to add in for DCO turnups, router turnups and removals, line card additions and removals, and then satellite additions and removals as well. And so over time, we're working our way to slowly working our way towards a more automated turn up process and take away as many hands as we can so that we can get this done quickly and reliably over time. And so I have a little slide here on network-based automation. I don't want to presume, or I don't want to accidentally imply that we have had anything to do with this particular one, but this is something I've been thinking about a lot, and I think it's worth mentioning. But our routers themselves have automation built in from the vendors. It's automation in a way. It's more about how the protocols work or the protocol features work. But I think it's worth noting that this is a form of automation. The RSVP protocol allows us to reserve bandwidth across the network, ensuring that we're using the shortest paths. And the way we've been doing, or the way it sort of works, that's kind of the reservation system is a form of automation, in my opinion. We're also using the MPLS protocol for the past 20 some odd years. We've enabled auto bandwidth recently, which allows us to, which allows the routers to make a determination on how much bandwidth is being used from that router to any other router that it's sending traffic to. And this allows us, traditionally, when we did this manually, we would do it like once a week. And those things would be based on one point in time throughout the week that happened to be the highest point of traffic usage. And in those cases, like if we used 50 gigs across a particular path, it would be stuck at 50 gigs 24 hours a day for the next 7 days. Now the routers are able to do this every 5 minutes or so, and we're able to free up capacity throughout the day when it's not needed, and then to kind of claw it back whenever it is. And so the network's able to kind of take care of itself in those ways, and it allows the traffic demands and the available bandwidth usage to be controlled, not by a human who may take much longer to do it, but by the network itself. And then all of our routers do support scripting, so we can put some scripts on the routers and we can enable them to, if there's a particular event that happens and we want to collect specific data off when that event happens, instead of the not getting an alarm up on their system, and seeing it and go, oh, this happened 10 minutes ago while we were busy with something else. We need to collect this data. Well, sometimes if you don't collect the data immediately, you lose it. These routers are pushing so much logging and everything so quickly that sometimes you got to be really quick. So these features that the vendors have built into their system allows us to put a script in place. And if those events trigger, it can immediately collect that data and store it and allow somebody to come along and pick it up later so that we can give it over to the vendor. And so looking at those benefits from earlier, this is definitely improves efficiency, reduces human errors. These works happen to help us with faster deployment, scalability, increased reliability, adds network security. Definitely brings cost savings in. Again, like all the other groups, the network engineering team, we don't have tons and tons and tons of people thrown behind it. There's a few of us and we're able to do a lot of work with fewer people. Gives us, helps us with centralized control, quick problem resolution. We got some work with some analytics and insights in there with the operational telemetry that I talked about earlier, and then helps us with adaptability. All right, so I'm going to cover the few of the benefits of network automation to the global IP network division and specifically. So one thing that we've kind of, network automation really helps with is, our costs have to be managed. IP transit pricing is just in a constant downward pressure. And so we need to make sure that costs are also always coming down to meet that or to in response to that. We are able to keep the operating costs low with this amount of automation. Using a template-based system for all of our configurations means that we don't need to get peer review or have a ton of people on staff to help, verify everything's good to go. Other telcos and other networks that I've talked, people running them that I've talked to, they have very cumbersome peer review processes where you can't make any changes without getting at least one or two people to look at it, and that can take weeks at times. Our templates are tested in advance in the lab and they're verified, and they don't make production until they're ready to go. And so we know that if we're going to make a change based in our system, based on those templates, when we push it out, it's not going to cause problems. It's going to do what it's supposed to do. Human error is extremely frustrating, and customers do value that consistency. We don't have, when we do provisioning and maintenance actions, they're planned, they've been tested in advance. There is no unexpected disruption of service. Things like router upgrades, even though I've just told you how great it is that we're doing it automatically, we're not just throwing new images out there and running the playbook to get it to upgrade. We're verifying that works and there's no changes and there's no hidden gotchas involved, so that we know that when we're going and we're upgrading routers, it's going to happen exactly when we say it's going to happen. We happen in the same amount of time we expect it to happen in. And there is no hidden surprises from anything that we're able to control. This also leads to higher quality of service, which is based on lower error rates, especially catastrophic errors. I can't tell you how many times I've heard horror stories or heard stories from in the news of networks going down for a large amount of times because of a human error or somebody typed the wrong thing, or it took too long to troubleshoot because they didn't have the data they needed in front of them to quickly determine what the problems were. And so all of this automation allows us to prevent those sorts of things. I think it's pretty safe to say that from a management perspective on our side, if we're not in the news, it's probably a pretty good day, especially given the last couple of weeks worth of issues out there in the world. On the networks. This also gives us improved service delivery, gives us consistency, allows us to diversify our platforms. We have 3 different vendors we're using right now for routing and 2 different vendors for optical networks. With a template-based system, we're able to diversify those platforms. We're able to diversify the vendors. We're able to make sure that everything is consistent with that. We're also able to do maintenances such as faster moves, during migration periods. We have a 3-hour window when we do migrations. We're able to very quickly move many circuits. I think in 3 hours, the most we've ever done is like 120 moves. And that's from brand new router, or from one router to a new router. So that's you're not going to do that very quickly when you're doing manual updates and you're not using automation. Also allows us to very quickly add new devices, add new line cards, add new, expand as we need to. And when we're shutting things down and we're migrating or moving to new systems, we can remove those old systems very quickly. We don't have to spend a lot of time trying to clean up the past and things like that. So we can remove that very fast. And also gives us, automation gives us extensive network visibility. All right. So now if anybody has any questions, I think David, if you want to join us again, you can, we're ready to do some questions, Q&A here. We got some time.
Yep, absolutely. But first, Joseph, thank you. Appreciate you sharing your insight here today, but we do have some questions, so let's jump right into those. So the first question is, what is the best way to deploy automation, especially for a network that doesn't have it set up yet?
Ooh, that's a great question. As someone who's actually when I started, we had automation in the network, but over time, I looked around and said we can do much better. So I've kind of sort of been through this a little bit myself. Where to start basically is the simple way to ask this question, and I think everybody has that. It's very easy to see where you can do automation because at this point, I think I'm of the opinion that you could automate everything. So it's very easy to say, oh yeah, let's just go automate it all. But once you start doing that, you're going to get snowballed and you're going to get, underwater very quickly. And that doesn't make a lot of sense. I suggest the way to start is for engineers and operators to kind of sit down and go, what is a task that I'm doing every single day and I'm doing it more than once? And just pick a very small, simple task. It doesn't have to be anything crazy. You're not going to have to go automate configuration management from the get-go. That's very hard, actually, and it's not something that I suggest starting with. But find something. Like if there's a particular report that you've got to do every week for a manager, or as we saw, we had a bunch of sales and management and directors here. If there's a data that you want on a regular basis, what your operators and engineers should probably be doing is figuring out how to go pull that and generate that port automatically and using automation. And that's a great place to start because you get a lot of experience doing something pretty simple and they bring value to your day because as directors and managers, you've got a lot going on. And, if you can get this information sent to you, or even the report can get generated and sent to your box exactly when you need it, then hey, it's a big win. So start with the small things and then build your way up because you're going to learn how the big thing. You're going to learn by the time you get to the big things. You're going to be like, oh yeah, I know exactly how to do that, and you've already got a good basis for how to do automation.
That's great advice. So we have somebody's also asked, have you seen zero-touch provisioning or scripting built into your layer 1 DWDM vendors as well?
Yes. We do not yet use zero-touch provisioning. A lot of the stuff I was explaining earlier about what we're building as far as the Python side of things go, and some of the things I was talking about earlier, is going to lead to that zero-touch provisioning. I like to look at it as I'm laying the groundwork for that currently. There's a lot of things that go into that. I've been thinking about it for a couple of years now. Traditionally, what you're going to see is zero-touch provisioning when it comes to the routing side of things. But the particular optical shells we use today, the current ones, they're based on Cisco IOS XR, and it has the exact same features that the routing side does. So we believe we can use zero-touch provisioning there. But we're already using our configuration management system to generate the optical configurations, which is kind of the hardest part. And at that point, just setting up zero-touch provisioning to grab the right software, the right configuration that it needs, and applying it, it should be pretty simple from that side. The vendor's kind of taking care of all those hard part for us, but we need to build the pipeline is what I'm essentially building now to get us to that point. And I hope in the next 2 years I'll be able to sit up here and give a great presentation on that.
That would be great. And let's see. So we have a couple of questions. These are pretty similar. Somebody's asked, most networks have small teams managing their network. For someone who's looking to learn more about automation, where do you recommend engineers should go to learn more? Along those same lines, somebody else has asked, somebody's looking for to learn more about automation? Are there any blogs, conferences, leaders, podcasts, or anything like that that you would recommend?
No, those are both great questions and very complementary to each other. Yeah, as someone who's on a small team, who's using automation to actually manage the network. And I mean, again, I've been here for 18 years, but I came into this situation where we had this kind of automation. It was crazy to see. It like blew my mind away that it kind of still does today. And I'm helping improve the system and maintain it and build it. So, to answer, I think the first question, if I remember the actual question correctly, actually, David, can you repeat that
sure,
question?
Absolutely. So,
sorry.
Basically, they're looking for to learn more about automation. So, where
learn more about automation.
You would recommend?
Yeah. So, there's a couple of years ago, there was a brand new conference called the AutoCon. I've been involved in all of those pretty heavily. I love that community. Network Automation Forum is the community who put that together. It's only about network automation. You may get some hyperscalers there, but they're not gonna sit there and give you presentations on data center automation or automation of other things. But they're there to talk about network specifically. And they do a lot of good work. They got a great Slack channel and some IRC channel and some mailing lists as well. But that's a great place to start, in my opinion. And then you can kind of roll over into the Packet Pushers Network. They got a bunch of great blog posts. They got a bunch of great podcasts. I think they have like 13 or 14 podcasts that come out every week or every 2 weeks now. I've done a couple interviews there myself, but I subscribe to their feed that gives you all of them on my Spotify account. It just gets downloaded, and I listen to them every week, and it's great. I'm as seasoned as I am, they're sometimes talking about very beginner and simple stuff, and I realize, oh, I forgot about that, or hey, I never knew about that, that kind of thing. Networking is vast. You don't know everything. Like, for example, I've never dealt with OSPF, which is a major protocol, and so learning things about things I don't know is great, and that's a great place to do that. I think Packet, which is PACT, is a good publisher who's publishing books on all kinds of technical topics, but they've got a great number of people who have podcasts on Packet Pushing Network Packet Pushing Network who have also written books based on network automation, whether it's on Python specifically or Ansible or just network automation in general. That's a great resource, in my opinion, to look for texts and stuff. And so I think those three places are really, really good to get started, and that's going to be an avalanche of information on its own. So,
great. Well, we'll include links to those resources in the follow-up email as well. So I'll be hitting you up for those, Joseph, if you don't mind.
Sure, absolutely.
So we can help people get connected. And just as a reminder, we do have a couple of questions left here, but if anybody else has questions, go ahead and get them in now, and we will share them with Joseph here. So somebody's asked, should a regional network have automation deployed?
I think any network should have automation deployed. I don't think it matters if it's regional or if it's a global service provider. It's every single network can benefit from it in some form or fashion. And like I was saying earlier, you just pick something small that you're doing every day. I like to say that automation's, great for doing all those mundane tasks I don't want to do anymore. After 25 years of being in this business, there's a couple of tasks where I just can't do it anymore. So I definitely have automation to handle that for me. And, I believe every single operator and every engineer and every person managing these networks can give you at least 100 examples of those kinds of things where they're just like, okay, like we just can't keep doing this anymore. And that's where automation can come in and help you, do those simple things. And, so it doesn't matter what size your network is. There's always something you could definitely automate. So.
And so this is the last one we have in the queue right now. So go ahead and get your questions in if you like. But somebody has asked, has NTT DATA deployed AI for network automation?
Not yet.
AI.
Not yet. I've been looking at some AI. I've got a little bit of a proof of concept going on right now that I'm working on that I'm not going to go into too much details on it, but we are playing with it a little bit. The way we do automation requires kind of a human to kick it off and do something with it, a human to verify it. It's a comfort level thing. I can see us using AI in some form or fashion in the future, but not totally autonomously. I still think a human's going to be involved. I think we can do things like have the AI make a decision or put something together and then have somebody come along and look at it and go, yeah, that looks good. Or no, let's not do it that way. Let's go do it this other way instead. So I can see AI as a tool, as a helper. When it comes to actual AI use, like today, all this Python I'm writing, all this coding that I'm doing, I am using AI Copilot and VS Code from GitHub to do some of that work and to help me with that. Sometimes, I'm sitting there, I'm trying to figure out the best way to do something, and sometimes it's easy just to ask the AI, say, hey, what do you suggest? How do you suggest I do this thing that I'm trying to do? Give me 5 different options, and sometimes, I can get a better idea that way, or I can have it look at my code and say, hey, what's wrong? What am I doing wrong? How can I make this better? How can I make this a little bit more concise? I'm a network engineer by trade. I'm not a software developer. And so having that help is really good. I mean, we do have software developers and teams of people who are more than happy to help me out, but they've got their own job too. And sometimes, I don't want to bug them, or it's, early in the morning or late at night, and I just want a quick answer. And, AI has been very helpful with that, but we're not using it for actual network automation at this point. But I say I will say if we do end up doing it, it's going to be very cautiously and very slowly.
I think your sentiment about it being a tool, to help you get there is echoed by some of the other AI experts we've talked on these webinars, as well as our Fiber for Breakfast. So,
right, and I'll go ahead and add on to
that cautious approach.
Right, and I think. So just to add on there, I just now thought of, but I think when it comes to networks, though, where AI is really going to shine once we kind of get to it is when networks just have so much data. There's just it's an avalanche of data that's hard to sift through, and the AI is going to be really helpful with that. I know a lot of the products we use, such as Splunk and things like that, are starting to kind of put AI into those systems, but I do sort of see that as probably the best and earliest use case, though. So,
yep, that makes sense. All right. Well, with that, I think that wraps up the questions we have for now. But I just want to once again thank you, Joseph. This is great stuff, and of course, thank you all for attending today. We appreciate you taking time to join these, and thank you to NTT DATA in general for not only hosting this webinar, but for the 2 others that they've hosted as well. As I mentioned, these are a series. The links are there in the resources tool, but I will include links to all 3 webinars will be available in the follow-up email that you'll receive to this. And Joseph, I'll try and get some of those links to those recommended resources that you provide as well for people who are looking to get more into more knowledge on automation. So really appreciate this. Thank you again, everybody, for attending. Just a couple of quick announcements. We are getting ready to wrap up our Regional Fiber Connect series for this year. These are our in-person events that take place in different regions around North America here. Our next one's going to be in Kansas City, Missouri. It's coming up pretty soon. That's on November 11th. If you happen to be in the Kansas City, Missouri area or want to travel a little bit to get there, we'd love to see you at these events. These are a little bit smaller in terms of the number of people, which makes them great for just being able to collaborate with others in the industry and to have some thoughtful conversation with your peers out there. So if you're interested, please do join us for those. Also, haven't mentioned this one in a while, but I would like to just highlight once again our Optic Path program, which is always growing. Very excited about this program. This is the FBA program that is helping to train and certify future fiber technicians. And we certainly need a lot of technicians these days. If you're interested in supporting us with this effort, please let us know. We are looking for volunteers to teach, but also just if you're interested in any more information about this, let us know. We'd love to share what we're doing with you. And lastly, I'll invite everybody to once again go out to fiberbroadband.org to our events tab, and you can see all the events that are coming up, both on-site, in-person events, as well as other webinars, including our weekly Fiber for Breakfast series, which is Gary Bolton, our CEO and president here at FBA, who sits down with industry luminaries every week for a half an hour to discuss industry trends, topics, things in the news. So please do join us for those. And with that, we will go ahead and wrap things up here today. But thank you once again for joining, and we look forward to seeing you on the next one. Bye, everyone.